Hi everyone. In this lesson we're going to use GeoGebra to graph a circle. Now here's the equation for the graph of a circle. We have x and y variables, and then we have h, k and r parameters. R is the radius of the circle and the centre point of the circle is at coordinate h, k. So to set this up we're going to have to begin by setting up some sliders for our parameters. Now the radius shouldn't really be less than 0. It doesn't make sense to have a negative radius. I might go only up to 5 and I'll go up in steps of 8.1. Now the value of h, that can also be a slider if I spell it properly. Now because this is an x coordinate of the centre, it could be positive or negative. So I'll just go from negative 5 to positive 5. Again, in steps of 0.1, and the same with k. So there's my parameters. I'm going to put a point, which I'll call C, at the coordinate h, k. Now, that will end up being the centre of my circle, and as I change h, you can see that the point moves, and as I change k, the point moves as well. So that's good. Now, we need our circle, don't we? So I need to write basically this formula referencing the values of r, h and k. X take h squared plus y take k squared equals the radius squared. Now my radius is 0, but if I make the radius increase, we can see that my circle behaves as expected. Let's put the centre of the circle at coordinate 2, 2, 3. There we are. And if I put my radius at 5, then you can see that's 5 steps in any direction to get to. So that one there is an interesting point. So down by 3, across by 4. So that's like a hypotenuse of 5. If you imagine a 3, 4, 5 Pythagorean triangle sitting there, there'd be another point over there, the same, 5 units away from point C. So 3 down and 4 across. That's, without drawing it in, there's a 3, 4, 5 triangle. And that's really the basis behind this formula, the Pythagoras theorem. Now let's have a point A, and this point will be this point will belong or be fixed onto the object called EQ1, equation 1, and as I hit the animate button, it just stays somewhere nice there. So that's okay. I might just pop that point there. Now I think I'd like to have a line segment running across from point C to point A. And that should automatically update dynamically. Yes, it does. That's good. Now, I don't think I want to call that F. So if I click on that, I can change the label of that to R label, and I might show the value of that one as well. So that's my radius there. That's good. Like I said, there is the difference between, it doesn't matter where I put that point. I could more or less draw a little right angle triangle if I could identify the point that belongs there. I might call that point B. Now that point B would share the same x coordinate as the centre. So I'll go x coordinate of centre, x coordinate of point C, and it would share the same y coordinate as point A, the y coordinate of point A. Now as I move point A around, then that point stays in line with there. As I move the centre to the left or right, it stays in line there as well. I need a couple of line segments now to complete this diagram. So the line segment from B to C, there it is, and I want a line segment from point B to point A. Now I want to, I don't think I want to see the label, but I would like to see the value of that one. And I might change the colour of that one to red, and I might make it a dotted line. Oh, I've got a lot of decimals on display, don't I? Now, same thing with this one. We'll make it red, we'll make it dotted, and I'll see the value but not the label. I'm going to fix those decimals. If I hit the settings, then I can change to a more reasonable, something like 2 decimals is more reasonable. So that's better, isn't it? Now, if I do bring that point back down to, of course I changed this, didn't I? If I bring that point back down to there like I thought, then it's as we suggested. There's a 3, 4, 5 Pythagoras triangle going on in order to see my circle. Now that is the fundamental basis behind this. If you think X and Y, they're the coordinates of point A, aren't they? And if you go X take H, remember H and K are the coordinates of point C. So if I go X take away H, that gives me this horizontal edge 4. And if I go Y take away K, that gives me this vertical distance 3. And of course, squaring these two is squaring the sides of the triangle, and radius is of the hypotenuse. So that's really just the Pythagoras theorem that we're employing here to get this equation. And it doesn't matter where point A is, they update, and at any point we like, then that number squared plus that number squared should equal 5 squared. That's how Pythagoras works. Now, that's a great little animation, great little diagram. I want to save this now, so I'll use the menu here to hit save. And GeoGebra, being a web-based program, it wants me to sign in. I don't want to sign in, so I'll continue here without signing in. And I'll call this circle dot GGB. GGB is the extension for GeoGebra. And when I save that, it'll go into my downloads folder, just like anything else. So let me just go and check my downloads folder, and there it is. So I did one earlier, but that's the one I just did there. Now, if I leave GeoGebra, so I'll just clear all that away. If I come back at some other time from the same menu there, I can open a local file. GeoGebra defaults to this online, cloud-based, and there's lots of people contribute to that, but if I open a local file from my downloads folder, then there it is, exactly as I left it, and everything still working just the way it was when we left off before. Okay, thanks for watching.